Okay, so there are going to be three different approaches we see. The first, and probably one of the most important, are the concepts of methods. So methods and classes. What are methods? Methods allow us to name a block of code such that we can invoke it by using its name. So methods are great because they improve readability and reliability. So you could think of, let's compare methods to a variable really quick. And so here, let me do this. Let's make a new slide, methods versus variables. Okay, so a variable, right, is a named data, right, that we store to use later, right? A method is named code block that we store to use later. So they're kind of similar. One allows us to store a particular value into memory, and then when we need it later on in our program, we can use it. A method allows us to ascribe a name to a block of code, and simply by invoking that name, we can call that block of code to do some work. So usually the difference, okay, so I said these are, what are the differences? So when we want to recall a variable, it looks something like this. I might have something like int x is equal to 10, right? And then I can say, for instance, do x is assigned, or let's do this. This is better. X plus 5. Okay. So what's happening here is I'm doing an assignment, right? And I'm taking the value of x, or the label of x, that is now being stored as an alias. So whenever I reference the value, the name x, whenever I use the identifier x, whenever I use the label x, all those words mean the same thing. Identifier, label, name, variable name. Then what's happening in the JVM is it does a lookup. It's going to see if there is a user-defined symbol. So maybe when you see an error block, it says can't find symbol, and then it points to whatever the variable name is. What's trying to do there is trying to see if you have a variable that has that name, and then it'll then go to that memory address that variable name is an alias for, and it'll pull the value. So this is how we use variables in the wild. And actually, what I want to do here is let's go to format. Let's make that, oh, that's awful. Let's do, yeah, let's remove that. Okay, perfect. That's a little bit better. Okay, so if we want to recall a method, suppose I have a method name. So suppose I already have a method defined, and let's also call that method x. So let's do something like static void. Oh no, let's do static void. Let's call this x. So it's very similar. Okay, so suppose I have a method that's called x here. Well, if I want to go ahead and invoke it, then it's going to look like this. So every time we call a method, whether we have to send an input or not, we always need to use the parentheses. So you know just by reading whether a identifier represents a named method or a named variable based off of whether it's just a name of something or if it's a name with a set of parentheses. Name with a set of parentheses indicates, hey, I'm trying to recall or invoke upon a method from memory, whereas here I'm trying to reference a variable. So just keep that in mind when you're reading your code. Okay, so let's go back to methods and classes. So classes can contain methods and methods can contain code, right? So we've stated this from the get-go. But when we first started doing this, we just ignored the fact that we can make user-defined methods so that we could just focus on the code. Now we're going to start focusing on building out methods. So understand, when we build out our methods, we have to put all of our methods inside of the class scope. So again, just like how we have been coding, we will define a class when we start building out our applications. Every application that's supposed to execute has to have at least one singular main method. So if we don't have a main method in the class, then that class can't be executed in isolation. It can't be the root of our application. It can't run. But we can have more than one method, right? We can create our own, but every time we create our own, we have to declare it inside of the class scope. So let's talk about method declaration versus method invocation. So declaration is when we first define the method, and again, all methods must be declared within the class scope. Invocation is when we invoke or call upon that method, and so we usually do that inside of other methods, right? So inside the class, we define a method. Inside of other methods, we actually use it to do a task for us. And again, the way you want to think about this is that methods are really used to talk with one another by sending data between each other. So there's two ways that a method can transmit data back and forth. You can either send data into a method from another method. So we send data by placing values between the method's parentheses. That's why the parentheses are important. That represents the important data that block of code is going to need to be able to process. Now, not all methods need any values supplied to it, but sometimes they do. And then also, again, there's the ability for a method to give back data or return data back to the method that called it to do some work. And so if we need to return data back from one method to the other method, we would use a return statement for that. So a return statement would be the very last statement of any method. And that's what's going to, when we look at the method declarations, that's going to be where the word void uses. So if you don't have to return back any data, your return type would be void. But if you did want to return back data and you can only return back one piece of data, right? You can only give back one thing on a method. Methods are hyper focused. Then where we would normally type in void, we can type in the data type that we're returning back. So if, say, for instance, we have a method that's going to return back a numerical value, an integer numerical value, then the return type would be int. And we have to put that in the header. And then to adhere to the contract, because you want to think of the header that we create for the method as a contract between what we're implementing in our code base and what all other methods are going to invoke. So the idea when we start making methods is you want to give your methods really good names that define what happens when you call this method. So typically what we do in Java, and this is true for most programming languages, is you select a good verb that communicates what is the action, what is the event, what is the sequence of statements that get executed inside of the block of code that we've labeled as this method. So the name should be very descriptive, and usually you want to think of it as an action concept. So again, usually, I don't know if I've mentioned this with variables, usually we think of variable names as nouns, and we think of method names as verbs. So we start building up this language that we can define in our code base. So we have things, and we can operate on things by sending them into these verbs. And again, when we have these verbs can take in data from another method, or they can return things back. Okay, so how does methods allow us to adhere to these dry principles where we attempt not to go ahead and repeat ourselves? Well, you can see there's 6 different ways here that I have listed. First, methods allow us to define an algorithm once and run it multiple times by using its name. That's super powerful, especially if you've worked on the zombie apocalypse game already. You can see it allows you to write something once and then repeat it an unlimited number of times without ever having to alter it again. Then if you have to refactor your code, you can just refactor the code that's inside that one method, and every place in your code base that invokes that method now will have that reflected change. Super powerful. It allows you to propagate a change by just having the implementation in one single place. Okay, number 2 here. Methods allow us to divide our algorithm into smaller parts. So as you might have noticed, having all of your code in the main method makes for a very unreadable main method. That's bad design. That's bad form. What we strive to do is make it much more manageable. And so what we want to do is we want to break our code base across multiple methods. In fact, and again, I'll mention this again, probably in the slide deck, but I'll mention it now too. A good rule of thumb is your method should never be over about a dozen lines of code. If it's over about a dozen lines of code, that should be a clue to you. Hey, maybe I should break this into smaller methods that then get called by this larger method that needs to do all these different things. Another rule of thumb is that a singular method should only have one job. It should only have one task. And sometimes that task is to manage or ensure that another set of tasks get done, right? That's what a manager does in a company. Your methods have a hierarchical structure. We'll talk about that in just a moment when we start looking at the top-down stepwise refinement, but I'll give you a kind of preview of that. You want to think of the main method as kind of like your CEO. If your application is like the hierarchical structure of a company, then your main method is like the CEO. And so the CEO's job isn't to do everything, right? It's to be able to have a collection of employees under the CEO that they can delegate to. And then those employees might be upper level managers themselves that have a number of employees under them that they delegate to. And so you finally get to a set of employees that are tasked with completing an action. The nice thing about a hierarchical structure like that is that you can look at any one piece and look at it inside of this tree of responsibilities and say, what is this unit responsible for? And if something has gone wrong with the application, if your application isn't working the way you anticipate it to, it's easier to debug. You can go towards the method you know that work's supposed to be going on at and check to see where the broken logic occurs at. Okay, methods make our code easier to implement and test a piece at a time. So you might have noticed as you're testing your code, if it's all in the main method, you got to test the entire application all at once. One of the nice things about implementing a method at a time is you can define a method and then you could test the input and the output to make sure it works the way you expect it to, even before the rest of your application is complete, right? So if you know, I can send this data in and I'm going to get this data out, you can make a quick mock set of tasks where you create a main method, you pass some data in, and then you see what the result is. A good indication of how a method can be tested like this is effectively the way that the labs are written, right? The labs test your code. They don't test how your code's implemented. It tests based off of sending input into your code and then seeing AutoLab then checks your input and sees if it gets expected output. And if it does, then you got credit because you did what the specifications for what that question was asking for. So that's what it means to be able to test effectively a unit at a time, where the smallest definable unit in a code base is a method. It's a block of code that we can give a label to. Methods allow us to divide our project into parts so that one person can work on it. So again, another nice thing about methods is we can actually distribute the labor of creating applications. Because I can say, you're going to write one method, you write this other method, you write this other method. And if each of the individuals works on the logic that's governed by one singular method, instead of having one person have to work on a complete application on their own, you can kind of divide that work across multiple programmers or developers. Methods make our code easier to read and follow. Each method has its own responsibility. I already mentioned that, but again, the value of your code blocks being responsible for an individual things makes maintaining and refactoring and debugging much, much easier. I will say that you've probably already encountered this, and maybe this is true or not, non-trivial, a significant amount of your time, so non-trivial, non-insignificant, amount of time will be not necessarily encoding or developing pseudocode or implementing, but debugging. So how have you found that true with the zombie homework? Since when you, especially when you start designing things on your own, you're having to test it out, you get all sorts of errors, or you get erroneous behavior, like you run into a zombie and it doesn't kill you, or the zombie kills you even though it's on the other side of the world, or maybe you're rendering movement like at a 90-degree angle. So every time you go up, you go left or right? Like all these, you then have to search out why it's causing a behavior you didn't expect. So all these strategies are designed to help make debugging as painless as possible, because that's the worst part of coding. The worst part of coding is when you've written the code, you try to run it, and it doesn't work at all, or doesn't work the way you want it to. So we want to try to make it easier to find out, well, where is my problem? It's easier to know, oh, let me check this method that's only 12 lines of code, as opposed to, let me look at the entirety of my application, which is 1,000 lines of code. It's also why you want to test often, so you can try to catch those bugs earlier on before your application is fully built. And finally, the main method should not have any implementation details. We have violated this concept tremendously because we didn't know about methods. But moving forward, we want our main method to effectively just be the delegator. And the only thing that should be happening in the main method is effectively the invocation of other methods, because that's going to make the main method much more readable. Like the goal of the main method is, again, let me step back before I finish that sentence. The purpose of our header comment is to, using just a natural language abstract way, tell whoever the reader is what this class is responsible for. Well, the purpose of a main method should be as readable as possible to see what the overall logic for the entire algorithm is. And so you don't want to show the trees from the forest in this respect. You want everything, again, you can give methods really good readable names. So if you have a collection of, say, 4 method invocations, I could read that as if it's a set of sentences and get a very clear impression of what is happening inside of your logic, inside your algorithm, to get from the initial state of the application all the way to the resulting state, right? To start with the beginning, work my way through the middle, and then get to an end, as if it were a novel, right? As if it were a story. And so each one of those methods then would contain the trees, it would contain the particular details that must actually occur for our application to run. And again, all these concepts work together to do what we call enforce self-documenting code. So again, all these strategies make it as easy as possible to reread through the code to understand what's happening. And this isn't just for other people, right? Even if you're working in isolation, after you step away from your code, and maybe you've already experienced this, maybe on the zombie apocalypse game, you stepped away from your code even for a day, you looked at it and like said to yourself, what the hell was I thinking when I wrote this line of code? Or you wonder, why is this working? Like, what was some of the decisions I made here? And again, these concepts are for our own practical purposes, so that when we have to revisit our code base a week from today, a month from today, 3 years from today, when it's been flushed out of our mind what the key decision points were in the way that we designed our logic, we can easily and rapidly remind ourselves. Okay, let's talk about methods and functional decomposition. When I first talked about the top-down stepwise refinement process, I said we could use it for 2 things. The first is we can start with a top statement, and using this iterative step-by-step approach, expand that top statement, that very simple summary, into a fully fleshed out collection of pseudocode statements. And the nice thing about pseudocode is very similar conceptually to a programming language, such that I can then select a language like Java or Python or C++, and then do a one-to-one mapping from my pseudocode to that concrete programming language. So in addition to that, with the top-down stepwise refinement, it can also help me define what should be methods. So now that we're talking about methods, we're going to walk through this process again and see how the refinement process itself can start breaking apart what should be clustered as a definable method. So actually, we're going to do a sample of this here so we can actually see what functional decomposition in the top-down stepwise refinement process actually looks like. So here it says we're going to see the averager.txt document. I embedded it inside these slides. So let me maximize my space there. Okay, so let's start the way we have started in the past. So this is my averager.txt file. We're going to start with the top document. So averager is going to be a little bit different here. So previously, we were just averaging a single collection of grades. But does everyone remember how our grades are computed in this class based off of the syllabus? I don't even remember. I want to say it's 30% is your lab grade. Is it 30% is your test grade and 40% is your homework grade? Does that sound about right? Let's just say that's what it is. I just checked the syllabus. It's usually around that level though. Usually it might be flip-flop the other way. Maybe it's 35 and 35 between tests and homework. But either way, right? The idea is that there's a weighted distribution to compute your grade. So whereas our other averaging program had an equal weight for all of the scores we were averaging, right? All we did was we summed the set of scores and then divided by the count of scores to get the average for whatever those were, quizzes or tests or homework. Oh, perfect. 30% test, 30% homework. And how much is lab? Is lab worth 40%? I thought labs were 30%. I don't know. I have to look at the syllabus. But suppose we wanted to go ahead and create an averager program that did something different than what we made before. Suppose we want to determine a student's average for any numbers of labs, homework, and tests, but it's a weighted average between the homework, test, and labs, right? So that's a little bit different. So we have to figure out, so in this instance, you might have 10 labs that you do, or 12 labs that you do over the course of the semester. So we'll take the sum of those and then apply a weight to that. And then we would have to add to that the sum of your homework grades, right? Find out that average, and then apply the weight of how much the tests actually mean to your overall grade. And then we would add to that whatever the average is for your homework. But then we have to apply multiplicatively a weight on that makes up the entire ratio of that. Okay, so with the top statement said, if I wanted to actually break this down into pseudocode, I would take the top statement, determine a student's average based on any number of labs, homeworks, and tests, and we will go through the refinement process. Well, the first thing we do in our refinement process, the first step is we initialize our data model, right? So we figure out what's the initial state, initialize data here. This is the initial state of what we will need. So we've seen that before. And then the second thing we would need, reading this, right? So once we determine what are all the things we're going to need, we're going to say, okay, well, we're going to also then compute an average for the number of labs. So the second block here, I'm going to say is, well, we'll get the labs from the user and sum them and count them. Then we would get the homework grades from the user and sum them and count them. Then we would get the test grades from the user, sum them and count them, right? So these are the three main types of grades, categories of grades you have. So we need to get averages for each individual one by collecting all the individual scores. And then once we have the average for the labs, for the homework and the grades, we can compute the overall average, right? The weighted average, and display that. So again, do you see how this refinement follows what we've done before? And so is everyone comfortable with this being refinement 1 from my top statement? How there's this organic translation where I take this thing that's abstract and I break it into a set of instructions that are a little bit more detailed. Now, clearly, this first refinement is still too abstract, right? So we're going to have to do another refinement. So in refinement 2, I'm going to highlight what statement I made, what more abstracted statement I made in refinement 1, and I'm going to consider it more deeply in refinement 2 and make some decisions, start making articulations on it. So when I say, oh, I need to initialize data, what I really mean by that is I'm going to initialize a sum to 0. I'm going to initialize a counter to 0. I might not even need any of this stuff, actually. Let me see here. I mean, I'll keep it in there. I'm going to initialize a count to 0. I'm going to initialize a scanner. Clearly, all those instructions are pulled from the old one we did. But here we also need to have separate things like a test average, a homework average, and a lab average. And finally, we're going to have to get a, let's change, I want to use the word final there, a total average. Final is actually a keyword in Java, so I don't want to be using that to be articulating anything. Okay, so finally we'll get our total average. So this is all the data that we'll effectively need. Now, I want to look at, in refinement 2, the parts 2, 3, and 4 all together, because I want you to notice something. In part 2, where I want to get the lab grades from the user and sum them and count them, well, to get those homework grades from the user and sum them, I would do this. I would repeat until the grade is less than 0. I would add the grade to the sum. I would add 1 to count. I would prompt the user for input. I would get the user input. And then after all is said and done, I calculate the lab average, right? So this is how we calculate an average for a lab grade. Well, if I look at it, well, we were doing the same thing, right? We repeat until the grade is less than 0. We add grade to sum. We add 1 to count. We prompt the user for input. We get the user input, and then that would calculate our homework average. And then finally, we would repeat until the grade is less than 0. We would add the grade to the sum, add 1 to count, prompt the user for input. Here, I'll put, instead of just input, let me put that this is for test input. Make it more clear. Let's say that we will prompt the user for, let's say, homework input. And then here for input, let me say that this is instead the lab input. Notice, for the most part, we're doing 3 different actions, but they're all using the similar or same set of logics, right? This, when we're developing our pseudocode and when we're see this behavior start to manifest itself, that's a clue to us, hey, that's a violation of the dry principle. We already see that right then and there, right? So here, 2, 3, and 4 are exactly the same blocks of code. The only difference is the prompt that it gives to the user. It's like, give me your test grades, give me your homework grades, give me your lab grades. And then finally, on the 5th part, we're going to calculate the final grade and then print that final grade out. So again, if I look at our process in completion, using that top-down stepwise refinement, this is what it looks like, right? So the top statement, we've already said, I can reuse that in my actual code base as my header comment, which explains to everyone else what this class is responsible for doing or what this application does. But what we haven't done yet is there's actually a use case for that first refinement. That first refinement should be very representative of what happens in our main method. That is the very abstract set of invocations of those methods that will get called out. So when we defined, say, for instance, and let's go back here. So going back and using this strategy, when in refinement 1, I said there's effectively 5 key concepts. There's 5 driving statements that get us from point A to our destination, then that is decomposing our logic from the get-go into what could be our methods. So we know we could effectively have 5 method calls in our main method to be able to complete the work that has to happen. Does that kind of make sense? And we're going to see that in practice. So we use our refinement 1 as a guide to figure out how many methods we're going to need to delegate to accomplish our task. And then finally, what we have in refinement 2 is our functional decomposition, where we define what's happening in each one of those blocks of code. So again, what you could think of it as, I said that a method is a named block of code. So what you could think of this is effectively the name, the name that we want, and this is the block that's associated with it. So this is one name and the block of actions that get associated with it. This is another name and the block of actions that get associated with it. This is another name and the block of actions that get associated with it. Okay, is there any questions and concern about what we're doing with functional decomposition and how it works in this top-down stepwise refinement process? So the next thing I want to do is actually let's see how much of this actually gets repeated. So my top is my header comment. Yep, step 1 is my main method. Step N is the methods that the main method relies on to accomplish the task. And again, sometimes if you have multiple refinements, so here we only have 2 refinements, what that tells me is that my main method is going to delegate its task to a set of helper methods, but those helper methods are able to accomplish the task in and of itself. Now, if I had helper methods, like in refinement 2, that were still not well defined, and if I had to go into a refinement 3, where I had to better articulate what was happening inside of one of the helper methods, then that represents that helper method needing another helper method to delegate some of the work. Does that make sense? So if I have, say, for instance, n number of steps, that lets me know I'm actually kind of building a tree of method calls, where my main method delegates some of its work to external methods, other methods, and sometimes those other methods can delegate some of its work to another set of methods. I can see how deep my method chaining goes by the number of refinement steps I take when I'm designing my algorithm. Again, this is why the top-down stepwise refinement process is a very powerful approach for allowing us to adhere to both dry and KISS. Because we can take the step-by-step approach to develop from abstract to a concrete set of statements of pseudocode, and then see how we step through that to see how we should break that down to make our code more easily modifiable and more easily discrete and more easily modular. Okay, so again, avoid putting implementation details in the main method. This is what we will adhere to moving forward. It should delegate the work to all other methods. The main method is like the CEO of a company. It's responsible for everything to run, but doesn't try to do all the work. It delegates it to other methods. Okay, and then this will actually be our implementation. Let me grab this. Let's actually go and look at this source code though. So we're not actually looking at it inside of here. And actually I'm going to cut this here. Okay, let's cut this out. And let's just start with something easy. Our public class dry averager. So this is going to be the name of our class. We're going to import the scanner object because clearly we're going to have to be able to get user input. So I'm going to do that now. Okay. So we said we're going to reuse the top statement. So the first thing I'm going to do is I'm going to go here. Let's grab this top statement. And let's start implementing this. So here, even before my import, I'm going to make a multi-line comment. Perfect. And I'll give myself the authorship. So the person responsible for this code, the person who wrote this, always give yourself credit. So again, so much of what's important when we start talking about software design is always identifying responsibility. So in our code base, our methods are responsible for a certain set of statements that get executed. And a class is responsible for a certain collection of methods that it contains. And so a developer is responsible for the methods and classes that they've authored. So if for any reason someone has a question about what this class does, it's important that you put your name on it so they know who to go to get more information from. But so that they don't have to ask you from the get-go, you also give the top statement. Okay, so now that we have that, let's see here. Let me grab this. Refinement 1, I said was going to be the main method. So let's go into here. Public static void main string array args, and let us put our comments in here. So let me toggle to line comment, and let me indent that end. And I want to indent one more time. And so this will be the set of, okay, perfect. So that's effectively the work that I want in my main method. And then, and let's actually start to flesh this out. So the first thing, actually, let's get here. Under initialize data, let's start with that, this part. So in the actual implementation, let's put this in as lines of code. So again, let's go to toggle line comment. Okay. And let's actually map this to our sample implementation that's given in the slides here. So here, notice that I have test averager, homework averager, and lab averager. Notice this right here is implementation details. That's part of my data model. But what I said is we shouldn't have implementation details in our main method. So we should cut this. So what we're going to want to do is we're going to want to declare a test average. And when we declare that, we can also get it from the user and sum and count them together. Let's see here, when we get this lab grade here, we can declare it and let me use the actual, that way it doesn't look like a logical operator I'm performing. And finally, so I'm going to merge these two concepts just for readability of my main method, because that's a consideration that I now have. So once I've identified what data I need, big picture wise, eliminated the little picture stuff, I can now say, oh, I can effectively initialize, because I can declare a test averager, and then I can call a delegator that gets it and sets it. So again, this is getting initialized by a delegator. Delegate to a method. Delegate this, the actual action of doing this, to a method. And delegate this to a method. And then finally, though, once I have these three things, then I can go ahead and calculate the average and print it. So again, this is setting me up to get the data I need, the initial data I need, and then process it out. Okay, so let's talk about this delegator that I have. So in this concept, I have get test grades from user and sum them together, right? So how do we do that? Well, let's go into our top-down stepwise refinement process. Or let's see if we can't just, no, not what I want. We've solved this problem before, so let's see how close to a solution this looks. So let's say that we will create a public static. So up to, for now, every time we create one of these helper methods, we're going to always make it public so that it's available internal to our class, but also external to our class. So for right now, we're going to ignore the other access level we could give to a piece of our code in a class, which is private. If we did declare something as private, though, it's available to anything else defined inside our class, but it can't be accessed to anything outside of our class. So if we wanted to, we could declare this private, but I'm going to keep it easy and just keep it public, okay? Eventually, we're going to use that other keyword, but we need to, it's good practice for us to put it. If we don't put it, it'll be defaulted to like package level, which I don't even want to get into that. So we'll be very articulate, just always use public for now. And until we start getting into being able to build instances of classes, which is going to be the tail end of this unit, we're going to make all of our methods static. A static means that this method is a property of the class itself, which means that it has a singular implementation. It has a singular rigid set of values, that it's non-malleable, that it can't have multiple instances that look different. Later on, we're going to learn how we can do cool things with classes where we can use a kind of a blueprint to create instances that manage its own set of variables, and each instance of a class can have different sets of variables. Like what that means is, imagine if we made like a zombie class, and a zombie class had like an X and Y, and each individual zombie can have its own set of coordinates. We're going to ignore that. And by saying we're going to use the static keyword, the set of values are going to be for the class itself. So there's only one set of values that the class can have, or one method that returns the same thing from the class definition itself. We'll talk more about that later when it makes more sense to. But for now, just know we need to use public and static to declare all of our methods. Then the next thing we're going to do is the return type. So here, we know we want to delegate this work to a method. And this is actually the first time we're seeing a method. Methods require three things, right? They require a name. So they require, and then they need to know what input might they need and what output might they need. So let's do this. Let's do this in an MVP build, minimal viable product. Let's do this as simple as possible first, and then we'll do a slight refactor. So suppose that, first of all, do we need to return anything? So we're relying on these methods to get averages for us. So what does that tell us? Does this method return something or does it not return something to the invoking method? And the invoking method, in this instance, the method asking to have some work done is the main method, right? So is our helper method, is the method we're about to define, is it going to have to give something back? Is it going to have to give data back to the main method? Yes. What type of data? Yeah, an average, which is probably going to be, we probably want to represent that as a fractional number, right? So numerical data that supports fractions, because if we compute an average, you probably want it to be like an 89.9 versus an integer, which would just truncate it and make it an 89. So that means we're going to start with the return type. So instead of void, like we did in the main method, we're going to say this does return something. It's going to return back a double value. Okay, the next thing is we need to give it a good name. So we're not going to adhere to the good dry method. We're going to refactor this. So here, let's say get test average is the name. And so what was that block of code to be able to get a test average? Well, let's go back over here and let's here. Right here, I think was, and I want to say just for, okay. So inside of here, let me grab this. Let me comment this out. Okay. So inside of here, what I'll do is I'll create a scanner. So here I'll call this keyboard equals new. So notice another thing is I could have created like a scanner in the main class and have to pass it around or all this other nonsense, but I don't. I only want to create the scanner when I need it, right? So I need it on this instance where I'm going to get a test average. So let's make it. So now we have our keyboard. Now the next thing I'm going to do is let's do system.out.print. Actually, let's just do print. And here, let's put enter test grade or -1 to end. Okay. Now we do our then let's do this. Let's get our grade. Double grade is equal to keyboard dot next double. Perfect. So we get a value. Then we can say while grade is greater than or equal to 0. We're just following along what we've done before, right? And then we will take our, we're going to need some more data here. So we need to, I should have deleted my data. I should have put it inside this method. So remember, we need to have a sum. Oh, hang on. We need to have a count. Perfect. Okay, so here I will then take my sum. Okay, let's indent, indent, and indent, and indent, and actually let's do this here. So I will take my sum, and then I will add to it my grade. Then I will take my count, and I'll add 1 to that. Then I will prompt the user. I won't prompt the user again. I'll just go ahead and prompt it once, make it easy. Then what I'll do is I'll just take and do grade is assigned the keyboard dot next double. That'll update my loop control variable. No, stop that. Let's get these comments organized in a more readable fashion, because I'm kind of, okay, perfect. Okay, so that's what we already had. And then finally, let's compute that average. So after this is done, we can then say, what is this? Our double average is equal to our sum divided by our count. Let's print that out. System dot, perfect. System dot out dot print f, and let's put something like test average, and then percent. Let's see, this is an f, and let's limit it to 2 fractional points. So I can put in between my percent sign and the f some formatting instructions, and then I'll put a new line, and then I'll give it the average. Okay, let's actually see really, and then remember, since I claimed that this returns a double, I then have to have the very last statement in my method return back something that is a double data type. That's going to be the average. Okay, let's actually test this one out. So here, where I said I'm going to declare my average and then get that from the user, let's actually do that. Let's do. So let's call this test. And I'm going to assign that to whatever I get back from this get test averager. So here, let's call this test average. And now I've done enough code where I want to test this. I want to see if this works. So let's do Java C. What is this? Try averager.java. So, oh, what's it say? So here, this is an important reason why we test. I actually misspelled printf. So I'm going to go here and I'm going to add that T. I'm going to save that. And now we're going to do it again. Let's go ahead and run that. And let's type in. Okay, so here, inner test, okay, or -1 to end. Actually, let me do a colon space the next time I test this. So let's test this out. Let's do like 100, 100, 50, 50, -1. And so test average is 75. Let's see if I actually get it inside my main method. So let's do a system.out.print f here. And let's, for now, let's just test, let's see here. Let's just test out our test average. So here we'll put test average is equal to %f. And again, we'll do, there we go. And then we'll put our test average there and we'll do a new line here. So let's run this one more time. So here, let's do 150 -1. So notice here, the second printout is coming from the main method. So notice we've delegated work into this method here. And so what we can do here is what we've realized is our logic is very similar. So I could do this, and then I could call this my quiz average, right? And then the only thing that has to change would be this. Now, everything and this right here, right? Everything else would be the same. So all I did was change 2 prompts, but the rest of my code is the same. Is that good software design based on what we talked in the beginning part of this course? I mean, this lecture. No, right? It violates the drive principle. I now have 2 methods that look almost exactly the same. So before I commit to this implementation, I see that I'm like, no, that's bad software design. Because now if I have to change the logic for averaging, and if I copied this again and made another one that was called get lab average, I'd have 3 methods that are effectively the same. Wouldn't it be better if I sent like a piece of text into the method that told it what the prompt was? Then I could use the one method for all 3 operations. One place of code that does a similar or the same kind of computation. So I'm going to get rid of this. I'm going to rename this from get test average to just get an average. But now I'm going to pass in a string. So in the parentheses, I could put data that this code block needs to perform its job. So here I'm going to pass in a string that says something like prompt. And here I'm going to change this print to be a printf, where I'll put %s, and I'll pass in what was given to me for prompt. And I'll do the same thing here. Instead of saying test average, I'll do %s, and before I give it the average, I'll also give it the prompt. Oh, got to spell that right though. So now I'll take this data that's given to this. Now that this requires data in, since there's a data type, since there's a variable declared in the parameter list, whenever we invoke this method, we have to give all the variables in the parameter list in the parentheses values. So now I can't just call this without supplying a value in there to bind to that variable. So here I'll give it test. Let's test it out and see if it doesn't look similar. Get grades from user. What did I do here? Oh, I got to also call this get average. Okay, perfect. Let's clear this and let's run this really quick. So now inner test grades looks exactly the same, 150 -1. And when I run that, it still says test average. So now look at how much easier this is going to be for me to implement. I can now do homework average, get average, and here I'll pass in homework. And now I will do quiz average, and I'll assign that get average. And here I'll put lab. And now what I'll do here is I will get the total average. And what did we say it was? It was like test average times, let's say it's 30%. Let's say it is quiz average. Let's say that was 30%. And or no, wait, did I do quiz homework? Yeah, lab. It's supposed to be lab. Let's make that lab. And then finally, let's call this, I have test homework. Yeah, homework average. And let's say that is 40%. Let's say for argument's sake, this is my weighted, the average plus times the weight, average times the weight, average times the weight. So finally, let's call this total average instead and give it the total average. Let's save this. Let's run this. What does it not like? I need a semicolon somewhere. What line? 13, line 13. Oh, here. Don't forget your semicolons. Okay, let's run this to see if it works. So I need test averages, 150 minus 1. Okay, so I got 75. Now I can enter my homework grades. So let's say 100, 100, 100, and let's say 75 minus 1. So now I have a homework average, 93, 75. Finally, lab grades. So 50, 60, 70, 80, 90 minus 1. So that is an average of 70, which, our total average is clearly, this is why we test. So let's see what happened here when we did our computation. Let's see here. Oh, this is not supposed to be a plus. That's supposed to be a times. So let's do that one more time. Again, this is good for testing reasons because you could say I didn't get the behavior I wanted, but because of the way I broke the code down, I knew exactly where in the code base to look. So I love when that stuff happens to me in practice so that you can see how easy this approach is. So let's do this one more time just to make sure it works. So we got a test average. We got a homework average, and now we have a lab average, and then that will compute a weighted total average that you get for your grade. And now when I look back at my code base, notice that effectively my main method looks at exactly like refinement 1 and is hugely readable. Get a test average, get a homework average, get a lab average, use that to compute your total average and print it out, right? Isn't that effectively refinement 1? And then we use our last set of refinements to figure out how many methods we're going to have and what code goes into our methods. And so here, all the minutia, all the little details are actually put into these helper methods that can receive data or it can return data. And in this instance, we need a method for both, right? So that we can build one method that gets all the averages. We tell it what prompt we want, and then the average we're going to get back from it, the numerical value we're going to get back. Is there any questions regarding this? Does everyone feel good about what we've done in terms of discussing or introducing the concept of user-defined methods and how we can make use of them to build better software? Okay, perfect. I will go ahead and let you all go today. I will make the test go live probably sometime later this afternoon, and we will talk more about methods on Tuesday.